All right. So good afternoon. I'm Noel Schultz from Washington State University, and this semester I'm helping coordinate the CySER seminar series. And so rather than talk a lot about what it is, I'm going to let my colleague Assefaw from computer science to share with you a little bit about what CySER is, as well as talk about machine learning research in CySER and go from here. So Assefaw, I'll turn it over to you and I'll monitor the chat so you don't have to. And what we'll encourage everyone to do during the presentation is put their comments in the chat, and then we'll go you want to do Q&A at the end, or you want to do it as we go?
We would probably want to do it at the end, but if people have something that is of clarification, we can take it as we go. No problem.
Okay. So thanks. Assefaw.
All right. Thanks, Noel. Welcome, everybody. Good afternoon. I know it is late for some of you on one time zone behind us. My name is Assefaw Gebremedhin. I am one of the co-PIs in CySER. I am with the School of Electrical Engineering and Computer Science on the computer science side. And I'm going to be doing our first CySER seminar today, this bi-weekly seminar we have. And I've got two goals. One of them is to give a little bit of an introduction, an overview to CySER. And the second goal, to which I would spend most of my time on, I'm going to talk about research that happens in machine learning. And this is going to be a peek. There are many people and many different ways in which machine learning shows up, and my view is going to be a little bit of a peek into it. I know some of you are already familiar with CySER and some of you may not be. And so beginning with what it is and having a common understanding would be helpful. So CySER is an institute funded by the Department of Defense through its Air Force Command with an initiative they recently have launched called VICEROY. VICEROY is an acronym for Virtual Institutes for Cyber and Electromagnetic Spectrum Research and Employ. That's a mouthful, but I like the acronym VICEROY. There are 3 institutes that are funded through VICEROY, and we are one of them. The other 2 institutes are the University of Detroit Mercy, who do things around autonomous vehicles, and things that are related with cybersecurity. And the other VICEROY Institute is at Mississippi State University. This institute of ours, called CySER, is in the Northwest, and that is what our discussion is going to be focused on. VICEROY has got an objective, a role to play in terms of training, a training that kind of merges together ROTC and a civilian workforce in a manner that is innovative. And CySER responds directly to that call by coming up with a cybersecurity education program that combines both undergraduate and graduate, but it is primarily its primary emphasis is on undergraduate education. CySER builds a strong consortium in the Pacific Northwest, and this is made up of 5 institutions, which I will introduce in a second. And these institutions are put together by having to look at the kind of community they serve and the strengths that they have, and they are complementary to one another. We had a little bit of a time to look for one another and find out where things could lead into good collaborations, and we have leveraged on that interaction we have had before successfully getting this program funded. One of the things that we would like to do when it comes specifically to WSU is to position WSU to attain a center of academic excellence in what is called cyber operations. And this is a designation given by the National Security Agency, and there are certain requirements that need to be made for an institution to be granted that Center of Excellence designation in cyber operations. And that will be one of the things that we want to achieve, and many of the things that we do now, and our emphasis is to set us in a place for that to happen. As I mentioned in my previous slide, CySER is a consortium of 5 institutions in the Northwest. WSU is one of them. The other 4 are Montana State University, University of Idaho, Columbia Basin College, and Central Washington University. And on this slide, you see the leaders and the different institutions and their roles, and in response to the Viceroy call, there is a selection we've made where ROTC in both Washington State University, University of Idaho, and Montana State, and Central Washington University are represented, and you see the leaders in terms of ROTC in this slide that you see. At WSU, the effort is mainly laid by people at the School of Electrical Engineering and Computer Science, myself included, but it has got also other people from different units within the College of Engineering. And the PI for this, Bernie, whom you know all, is with the School of Chemical Engineering and leading this effort in administrative sense and in terms of leading the collaborations that happen with other institutions. What I would like to do before we get into details is to give you an idea about what sort of things happen within CySER. And this is a good pictorial view, a pictorial summary of the activities we have, and I'd like to call them program elements. And this is the place where you probably would want to, if you have questions, to put in the chat, which Noel would monitor for me. In terms of trusts, the things that would define what CySER does in terms of research, which would be integrated, which would be integrated with the education aspects. The three trust areas are cyber-physical systems, AI and machine learning, and socioeconomic networks. In the later portions of my presentation, I'm going to make it a little bit more concrete and tell you specific topic areas we focus on, but that is the three trusts we have. With this as trust, this is a training effort, an education program. We have an undergraduate program focused on Bachelor of Science in Computer Science primarily, and with the intention of having the Center of Academic Excellence in Cyber Operations, this will be the program that would make the most sense to introduce new things that are needed. This is for computer science. At WSU, we also have a separate program in software engineering, and many of the things that we have designed to be made will be satisfied by students who are in our bachelor's program, either in the Bachelor of Science in Computer Science or in the Bachelor of Science in Software Engineering programs. But many of the ROTC cadets we have and other students who are interested in cybersecurity may not be computer science majors. And so we have a focus for those type of backgrounds that will be another category. We also have graduate programs that would be involving graduate students who have one way or another their research focused on cybersecurity, but also being a training program, we have creatively designed ways in which they would mentor undergraduate students in research activities that they would do. In addition to these three categories of students to be trained, we have as a goal to reach out to students in high school and work towards better awareness of cybersecurity in K-12 type of areas, and especially in high school. And we need more of those in these days. So this kind of greenish bubbles that you see in this picture are these categories of people that we target in terms of training programs. But what would they do? Research is an important component in the education. There are, as we speak, things that we have done to design new courses and incorporate into our existing curricula cybersecurity components, but many of them would be focused on projects. And these projects would come in various ways. In some cases, it will be senior design courses, if they are computer science students, for example. If they are graduate students, their thesis work would be an opportunity for doing projects. Or in many of our courses, the courses themselves will have as a semester project or a part of the course that they would do research. This is where the place for projects would come. One of the things that we have promised to do through the time where CySER is under funding for the next 2 years would be to involve students that are enrolled in this program to have an internship opportunity. This could be in military installations, on national labs like the Pacific Northwest National Laboratory or the Idaho National Laboratory, and a number of industries that are close to us, including the Schweizer Engineering Laboratory that is right here in Pullman, with whom we have close interaction and collaborations. We've got a good number of industry partners that are supporting our program and have committed to take students for internship opportunities. Another thing we have promised to do is to do an intensive 2 weeks workshop in the summer that will combine things that are technical and things that are about professional skills and some of the best practices in industry. The last piece that is in this ovals now, which is what we are here today for, is our seminar series. For this fall, we have decided to have a bi-weekly seminar, and this is the first of them. And we will do this to engage within ourselves and also to others who are visiting. And this would cover topics that are current, and sometimes, depending on who the speakers are, they could be from industry and they may have a little bit of an outreach nature. And we were fortunate to have an inaugural seminar before today's a couple of weeks ago, where a cybersecurity panel that SEL partners did at WSU, which was featured as one of the things that happened in a week that celebrated collaboration between WSU and SEL. And that happened a week ago, and our website has got a recording of that if you did not get a chance to attend it live. These activities that I've told you, the program elements, are going to be formalized in the form of certificates, for lack of a better word. And we have got 3 versions of them. One of them, the more demanding one, we will call it CySER, Cyber Academic Excellence in Cyber Operations, or Center of Academic Excellence Cyber Operations, fundamental to mean undergraduate. And this will require us to do things that we have, just as we speak now, is being processed within the faculty senate at WSU to approve 3 new courses we have designed at junior, senior, and graduate level, and a number of other electives, and many of the program elements I described in my previous slide. This will be targeted for computer science students who are looking for doing a Bachelor of Science in Computer Science. For this other category that I showed you before, we will have a certificate that corresponds to them that we have decided to call CySER Basics, and this will be for non-computer science majors, and typically it will be ROTC cadets. The first certificate program will be led by EECS at WSU. The second one, the Basics, will not have new courses in it. It will rely on information security courses we have at our College of Business with the Management in Information Sciences and Entrepreneurship, if I remember that correctly, program, and that will be where this will be housed. The advanced certificate will be for graduate students, and we have decided to leave that open in terms of where students are majoring, other than requiring that their research, their thesis, will have some cybersecurity focus. This is the place where I have said I will give more specific topic areas in terms of research outside of or that are more of a breakdown of the 3 trust areas that I told you. And here they are. Cyber physical systems is one of the research topics. Networks and information security is another. Machine learning and AI is the third. Software security and quality assurance is the 4th, and cyber education is the 5th. And many of the people that I listed in one of the early slides were people from different institutions. This represents all of the research efforts that would come from the different institutions, not just at WSU. And so what I will be doing today will be a pick on machine learning and AI, but this topic itself has got sometimes connections with very many of these other areas. For example, it may have connections with cyber physical systems, and sometimes it may have connections with software security and quality assurance. And so this is going to be give you a flavor, but for now, what I would be focusing on will be on things that I do. This will be a good place to tell you. I got help from my PhD student, James Halverson, and many of the things that I would be talking about now are on the research that he does, which is entirely on cybersecurity, and both in terms of what we are going to be looking ahead and in terms of things that would fit into CySER in a good way. And so this is the picking part. So what I have done so far was the overview on CySER, and from now on what you would hear will be where does machine learning fit here and where does cybersecurity as a main problem to talk about it. And you can get ready now for having some detailed research type of presentations. Cybersecurity is a main problem. That doesn't need a statement to be made. I think we are all aware. Our world is increasingly cyber dependent. We have making cyber attacks profitable to entities for attackers and costly to the victims. And various technologies make it easier for cyber criminals to hide their identity and evade prosecutions after the fact. What you see on the right is what the cost of cybercrime is, and this is from a source that is recent at 2020, and it's in trillions of dollars, and I have indicated what the source of these figures is, and that is staggering. This amount of money that is costing, this is the hidden cost, both the thing that has come as a direct effect or sometimes as a loss of productivity, but this amount of money, in addition to other interruptions that we may see in life, is major. State actors also play a role, and they may target critical infrastructure, and this is one of the things that we care about and would like to get solutions for, and Power Grid is one of those examples. Unfortunately, there doesn't exist a silver bullet solution to preventing cyber attacks. Software is increasingly complex, as we all know, including the ones that we routinely write, and there will be inevitable to have bugs in some, and that will be a source for cyber attack or for attackers to use. And this would be exploited by attackers. But even if software was not vulnerable, people are. And this can be manipulated into gaining access. So a persistent attacker may eventually find one way to get foothold and obtain unauthorized access and cause damage. And the unfortunate part is victims may not know if there has been a breach until it is too late. And by the time they discover it, the breach has already been done. Then what would a solution be? For mitigating a strategy to work, we need to know when you are being attacked. And so suppose, and then I'm going to have two things now to consider, and the second part of this is going to come at the very end of the presentation. So suppose we collected data on network and machine behavior, and we use software to look for signs of intrusion. This will be a great thing to have. Such a thing, if we build it, would be called an intrusion detection system. And that would be a good solution for us. And this would have two problems to it. One is, what are the signs for intrusion? The second is, what network and host data are going to be relevant? And the second part is the one that I would come towards the end. So let's look for what the signs of intrusion are so that we'll be able to build good intrusion detection systems as a solution for having to deal with attacks. There are two types of intrusion detection systems. One of them is called signature-based, and the other one is called anomaly-based. Signature-based is what the name would suggest. We're going to be looking for a list of known indicators of compromise. And once we know what they are, we go look for them. Virus scans are a good example. So if we know what they are, then we look for a file and try to look for where these viruses are happening. So we can detect attacks using these older, well-established techniques. This one won't be able to help us detect attackers exploiting undisclosed vulnerabilities. By the very nature of it, we're looking for things that are known to exist. At least going for it, this method has got low false positives for attacks that can be detected. An alternative way to doing this would be based on anomaly. And what we are going to be doing here is to have a model where we model what is a correct normal behavior. And any time we see a deviation from it, then we would see it as a sign for an attack. So this can be detected both for known and unknown types of attacks, which is an advantage compared to the signature-based. But the problem that will be associated with this, however, would be we may have a model where there is high false positive. So we'll always be generating false alerts, and people may get tired of it and not use it if there is too much of false positive rates in this. Machine learning is where this fits in. So my promise in the beginning of the talk was to show where machine learning is used. So anomaly-based intrusion detection systems would use machine learning models to develop things that would avoid having these high false positives, and more complex model to separate between malicious and benign behavior. Now that I have brought up machine learning here as a way to do intrusion detection systems using anomaly-based methods, an issue would immediately show up itself, and that issue would be data. Every IDS would require data to build a model of what behavior is and what isn't acceptable. Unlike many other things, we do not have a whole lot of data on high-quality cyber attacks or attack data. We don't have it both in terms of quantity, and we don't have it also in terms of quality. We need both malicious and benign behaviors in the same data set so that we would be able to build models that would tell apart which one is malicious and benign. And so it's not enough to have just the ones that are malicious, for example, because then we would not have a model that would have the chance to know what these differences are. So that's one. The other problem that is related with the data issue in intrusion detection systems that are based on anomalies is that we are going to be to label these behaviors, and that is laborious. This is not special for cybersecurity. It is also true of many other things. The moment we are asked to label data, we are going to be needing people. We're going to be needing people who are experts, who know in that area and be able to correctly label these things, and that is laborious. Setting up simulated attacks for malicious behaviors is also laborious. And if we are going to rely on companies that have had experienced attacks in the past, they may not wish to share their forensic data because it's anonymized. And then there is another issue that makes for why attack data is poor in quality and quantity. It is because it loses relevance after a few years. Whatever was a data that we had in some time is very quickly going to be irrelevant, and so has to be made. If this is the issue we have, then we may be looking for a solution somewhere else. If data doesn't exist, then we might be tempted to think about, or one solution might be to synthetically generate it. So if using human labor to create data is difficult, how about synthetic? And this is where machine learning comes as a way to solve the problem. And there are two solutions, at least present-day machine learning methods could be used to synthetically generate data. And those two methods, which I will spend some time on discussing today, are generative adversarial networks and variational autoencoders. These are needed to synthetically generate data, but they are also useful to make data that is scarce and available to us a little bit better. And I'll call this data weak data. And some of the weakness might be because it was not balanced. Many of the things that were about the benign and malicious data was skewed one way or the other. And so we want to have a little bit of balance, or they may have some other quality that makes them lack diversity, for example, and we want to mitigate that by having our synthetic data generators build upon them. So let me spend some time first talking about generative adversarial networks. These are one of the most well-known modern techniques for generating synthetic data. And the basic idea here is to train two neural networks in an adversarial fashion, in an adversarial process. One is for generating and the other is for discriminating. And the genesis of these methods is they were suggested some 10 years ago now, and they have been found very effective in image generation and gradually have found their way into being used in other areas, including cybersecurity. Here is an example of what they could do when it comes to images. This high quality image that you see are people that don't exist. This is actually taken from a website that's is called This Person Does Not Exist. And this is produced using a particular kind of GAN called style GAN. And it producing very high quality, as you can tell, of images, and these are not people, these are generated by GANs. We want to see if there is a potential for generating this quality synthetic data to solve the problem of insufficient data sets for intrusion detection systems. So that's the goal, that's where we want to head, and let's see if GAN may help us get there. And I want to first talk a little bit about how GANs work. And I have already introduced the fact that it uses two neural networks in an adversarial fashion, and here is how the training process in GANs work. For those of you who have had an exposure before, it will be a little bit of a reminder. For those who have not, this might be your chance to see in one slide how GANs work. So each GAN, generative adversarial network, consists of two neural networks, a generator, G, and a discriminator, D. The generator, G, takes random noise as input, and it outputs the type of data we want to generate, G of Z, as the figure on the right shows. That's what generator takes in and gets out. The discriminator will take what the generator gave it, and it will also, in addition, take real samples. I'll call that X. And the job of the discriminator is to tell apart which one is real and which one is fake. And that output of the discriminator is going to be a label. It's a classifier, basically. And so the performance of the discriminator is then fed back to the generator as a loss function to make the generator better at what it was doing. And so it takes that as an input, and this time it tries to get better data to give to the discriminator, and the discriminator in turn gets better at trying to still tell apart whether something is real or back. So this iterative process continues, and we say the GAN is trained in this fashion. So how can GANs, now that we know how they are trained, how can they be used to intrusion detection system development? So aside from generating the data set, the GANs could be used to do intrusion detection systems or things that are related to them. For example, the discriminator can be modified to classify malware and benefits from the adversarial process. So with a modification to how it is being used, we can make it become an intrusion detection system. The generator can also be used to create adversarial samples for an IDS so that it can discover weaknesses that can be fixed. This is a tool, but there are many other ways in which the GAN, in addition to supplementing the data, the one that is scarce, the one that is probably not of good quality, to make it better, it can also be used to make better intrusion detection systems. So James is working on having to see this from multiple angles, and here is one of the picture we have on a survey paper we are writing, and whenever you see a section there, that is a section that is being written where these GANs are being used, and this is a little bit of a systematic way to look at things that already exist and things that we project can happen in the future. All right, that was what GANs do and how they may fit into intrusion detection systems. But they've got known problems. And people who are working with GANs, including things that happen in my lab, are very much aware of this. And they constantly try to look for solutions to find or go about them. This adversarial process that's used for training can make optimization. And by optimization here, I mean the mathematical problem that happens in this adversarial way, which the two neural nets are trained in tandem. And these challenges are of three types. One of them, and I'm going to make this intuitive way to define them. You could also look at this in more mathematical terms, and some of the terms or the ways the problems are described here kind of invite or invoke those mathematical notions, but I'm going to tell them in English. One of them is called vanishing gradient. This is the case when the discriminator performs too well, that makes the generator cannot effectively learn from it. That is what the vanishing gradient. That's one challenge. The other one, a more common one, is what is called mode collapse. This is when the generator learns to produce just a few good samples and thereby succeeds in fooling the discriminator, and nothing more happens. That is what mode collapse means. The other thing is failure to converge. This is when the generator and the discriminator do not reach an equilibrium. Equilibrium is what you need to reach for the training process to stop, and this would make the performance poor. Some of these problems that are known, and these are not particularly about cybersecurity data, it could be anywhere where GANs are used. This is GAN shortcomings in general. People have come about to mitigate them. And this could be mitigated, for example, by having appropriate loss functions and or regularizations that could be incorporated in the model, or one can go look for other generative models than GANs. And one of these other generative models than GANs that we can consider is variational autoencoders. I have introduced this in my earlier slides as one of the two ways in which synthetic data could be generated, and let me spend a little bit of time talking about them now. Variational autoencoders are another way to generate machine learning model. Interestingly, they were introduced about the same time as GANs, where they are architecturally similar to existing autoencoders without the variational part. And there are two neural nets again here. Encoder that converts the data into some condensed or latent representation. That's what the encoder does. And the decoder takes it back. It reconstructs this data from that latent representation. Unlike traditional autoencoders, this adds an additional step to decoding from that latent representation. That's where the variational part comes. And this could potentially help us get around the shortcomings GANs face, especially when it comes to mode collapse. That doesn't make them a winner. They have their own shortcomings, which I will talk about in a second, but at least they are positioned to solve the particular problem called mode collapse. Just like I have done with one slide how the training process works in GANs, let me use one slide to show how the training process works in variational autoencoders. The nice picture that you see at the right is borrowed from the website that's cited there. And as you can see here, we've got the encoder and the decoder. These are the two neural networks. The encoder takes the input X and turns it into an output that is a statistical distribution. And being a statistical distribution, we've got the mu's and the sigmas there trying to say what it is doing. And that is taken by the decoder. This was the encoder. The decoder, it takes it from this distribution and it attempts to reconstruct what the input was to the original data. And for this one, a loss function is used. And that loss function is applied, and it's got two parts. One is the part that says how far of a mistake we have done between the input and the decoded part, the X and the X bar, the hat and the blue and the orangish kind of color that you see here. And then there is the second term that is about the KL divergence between the latent distribution and the standard Gaussian distribution as a regularization. This is how the autoencoder would do. And this is done in a manner that would ultimately make this loss function be minimized. Applications of variational autoencoders to IDS, just like I have said how the GANs were used for intrusion detection systems, we could envision variational autoencoders to be used for IDS also. They have been used, and we can theoretically think of them as they could be used every place where GANs are used, but it doesn't look like they have been used as much. And there seems like, and James is convinced that more work needs to be done towards using variational autoencoders itself as an anomaly detector. One, for example, way a variational autoencoder could be used for doing an intrusion detection system is to use it to train on benign data, encode possibly anomaly behavior using this variational autoencoder, and then try to draw samples from the probabilistic distribution, test on the probability of reconstructing the original data, and see if that anomalous behavior should not be reconstructed from this. This is one concrete way in which a variational autoencoder could be used to build an intrusion detection system. And there are other ways in which one can envision to try to do. I have given you a few list of things where generative adversarial networks in general, not just in cyber security problems, but other problems where their shortcomings are. And a similar way of looking at variational autoencoders will be worthwhile. When it comes to image generation, variational autoencoders are known to produce blurrier results. They're not as sharp as what GANs would do. Here is an example of numbers generated using GANs, and the one on the right using variational autoencoders, and clearly it is much blurrier. In terms of how they have been used, they have not been studied as much as GANs have been. And we did a couple of days ago a Google search on how, using variational autoencoder and generative adversarial networks, and the variational autoencoder search on Google Scholar gave like 34,000 results, that is, whereas the same search using GANs gave like 3 or 4 times, 124. So they're not studied as much. You could interpret this in different ways, but at least they are not studied as much. And they could be more complex to implement than GANs are, or autoencoders are. And that might be another reason for knowing them. I've walked you through, I hope you are following me along, and both in terms of seeing where synthetic data generation would come in using GANs and autoencoders, variational autoencoders, and in addition to being just replacing or augmenting data, synthetically generating, they could also be used to design intrusion detection systems. But one of the things that I posed in the beginning was we need to have a way to get data in terms of what network behavior should we observe to get. And that is what I'm returning to now. This is about observability, a problem in cyber monitoring. So what we asked in the beginning, or what I asked in the beginning, was what network and host data are relevant. And there are tools that exist for collecting forensic data from computers. And some of these tools could be seen either in terms of tools that would help find flows in networks, or they could be systems that would track logs. NetFlow and PCAP are 2 examples of the former type, and system logs and event log-based methods are others. This is about tools for collecting forensic data from computers. Here is a challenge that we need to face now. If we were to collect everything, which means you have more data to process, and we would potentially have a lot of false positives. That is when we collect too much. If, on the other hand, we were going to collect less, then we may be in a position where we lack enough means of indicators of attack. They may not be observable. So we need to find a way to find an optimal subset of features to collect. And this is what observability means. And this is where one of the earlier works of James comes in, and his tool is called Tomato. Tomato stands for Threat Observability and Monitoring Assessment Tool, and this was one of the early works for addressing the problem of observability. And there is some interesting things about using things in a manner that we can associate scores with, and this is about observability score for a pair of hosts on a network, given some configuration of monitoring tools. And some simulation technique based on Markov models was used to assign scores to a pair of hosts. And they could be having interaction between themselves in various ways. So this observability score is based on a probability of an attack occurring between 2 hosts in a simulated series of attacks over the network. And the probability of an attack having features that could be observed in the current configuration would determine what score we would associate with that pair of hosts, or a pair of hosts again. So this is then used to determine the observability of the net flow over the tools in a test bed environment. But this was done for a limited setting. And one of the things that James would like to do in the future is to extend this for other works. And this is, I'm going to be using a couple of slides to show you where this is headed. One of them was already introduced in one of the places where I was introducing GANs, where they were used for designing intrusion detection systems. But we could also look at not just GANs, but other generative models, including variational autoencoders, to see how they could be fitting into IDS development. That survey paper is currently what we're working on. The other thing that is related with GANs and is not limited to only to cybersecurity, but other places where GANs are used. Other places where GANs are used could be places where we have time series data sets, for example, is to find ways to improve the performance of GANs. The standard way in which they are trained would usually have limitations, either in being not being realistic enough, or sometimes not getting us the goals we have had set for the GANs to begin with. For example, if one of our goals was to increase the diversity of the data sets to overcome things that we lack in things that are observed, then there is a problem in getting that what we wanted. And so there is an active research that needs to happen that goes there. And that actually would be a good way to get me to the planned works, because this one would bring in a number of interrelated issues. One of them is to come up with a metric to see when to know what our GANs are doing is good or bad. One of them is to, for example, to see the performance of the GANs on what they do on things that are synthetically generated compared to things that are real. So train, for example, if it is trained on synthetic and tested on real, that will be one metric. Or we could have a number of other ways in which we measure how well a GAN is doing. That will be a question of metrics. That is a problem that is not solved, whether it is for cyber attacks or other kinds of problems. The question of what generation methods should be used. Should we be using GANs, or should we be using variational autoencoders, or do we even have to always be looking at machine learning based methods? So generation of methods is a related issue. And then the question of monitoring what data types to use, including what Tomato did with net flows, pickups, and log-based types. When all of these things are put together, then we would be able to evaluate synthetic data for cyber data applications, and we may have a good way to measure performance. And this is where IDS detection belongs in, and what we will be looking at in terms of planned work. This would require a lot of experiments to be done with generative models, and it would also require a lot of insight into other areas. And this is going to be my last slide, and I know I have tried to cover what I wanted to cover, but I want to leave time for discussion, so let me stop here and take questions. Noel, if you have been monitoring, and if there were questions, I'll be happy to start to address them now. This is my last slide.
I do not see any questions in the chat.
All right, then we could open up the floor for questions now.
Great. Does anybody want to ask a question? Yes. Who? Sorry, I've got.
I can stop sharing.
Oh no, Clem, go ahead.
Yeah, I had a quick question, and I'm trying not to jump in front of students, and so hopefully I'm not taking anybody's spot, but thank you for that presentation, Assefaw, that was great. I have a student that's also working on the generation of data for testing intrusion detection systems, but they're using metamorphic testing, and I do not know if you're familiar with those terms, but it's not model-based and it's not machine learning. And so I'm curious if your student has also looked at I guess, AI or machine learning techniques for generation of data.
That's exactly the thing that I included in the last box. We haven't.
Okay.
So this would be interesting to see what machine learning based models would do compared to other type of models for generating data. My preference would be to, or not preference, but what we have seen is machine learning based models, but it should not rule out other methods. So I'm not familiar with the method you just said, but it would be an interesting comparison to make.
Yep. Okay. Thank you.
Sure. You should feel free to ask questions, especially students. And I intentionally left a few minutes in the end, so all questions are welcome, or any question.
Welcome questions from faculty, staff, students.
Are you able to hear me?
Yes.
Okay.
Sure.
Great. Yeah, Bernie Van Wee here. I'm kind of helping lead this group with Noel and Assefaw. We've been looking into how can cybersecurity be used in biotechnology, and we're aware that people create these gene sequences or DNA that is going to be manufactured to produce proteins. And there's been some hacking that has taken place where people are inserting sequences that cause the formation of a virus or a toxin or that kind of thing. So we're now seeing a change in the sequence other than what was supposed to be there. And I read a clip in Nature Biotechnology. There are not real good means for detecting what the virus sequence looks like, or a toxin sequence looks like. So do you see the machine learning being useful in this area?
So sequences that are not behaving the way they are supposed to behave is one of the things I do, but not in terms of seeing them as malicious things that have been introduced. That mutations is what they would be called. So I am pretty familiar with things that you could do to find out where things are not in the usual way where they should be, or to try to find patterns, but they have never been machine learning based, in my own research at least. But I don't think it is such a bad thing to think of them as in the form of an attack. And so I am more aware of things that are not machine learning based.
Mm-hmm.
Things that are about having to study the sequences for what they are and find behaviors that are anomalous, basically, but not machine learning based, not to predict them, not to detect them in that sense. So, but I am quite familiar with other ways to do it.
Thank you.
Sure. There is probably a question about internships that maybe Noel you can see, and we want to make sure that we address questions like that before we finish, I guess. So I don't see the question anymore, but if you've seen it and you have an answer, please.
Yeah, the question is, how would you go about applying for an internship as an undergraduate?
Ronnie, do you have a good answer for that?
So I think I can add, one of the things is, because we have people from multiple campuses, is to go to our website, and I'll put that in the chat, and see who the lead is at your particular university. And then, because this is being recorded and others may be, I don't want to just address one person, but address everybody. And then what you should do is find the leader and email them and ask, or one of the leaders, and tell them you're interested in learning more. We are working both with the government as well as industry, looking at potential internships. So we would encourage you to go to the CySER website and talk to the leader about that. You can also email myself, and I'll put my email in the chat, and we'll get you connected with the right person. So anybody else want to add to that?
That's a great answer, I think, from what we know so far.
And there's a list of government internships that we've been given that you can now start applying for. And a lot of these are support internships for military. This is a DoD sponsored program. So they are looking for the training of a lot of people to help with cybersecurity in many different areas. And then we've got a list of companies that kind of are affiliated with our grant, and they have said they would entertain students for internships that are associated with the CySER program.
All right. Okay, and thank you. Clem has put up at Montana State, there's also an REU site that you could look at, and that link is there as well. So great. Well, I think we're out of time. So thanks a lot to Assefaw for kicking off our official every other week webinar series. In 2 weeks, we will have University of Idaho will provide an update. And then after that, in 2 weeks, we will have Montana State give an update. We'll then gonna skip a week, skip a little, and instead of Thanksgiving week, the week after Thanksgiving, we'll have another seminar, and we're working on that. So thanks everybody for participating, and we appreciate, we had a good crowd, about 25 people, and we will get the recording out so people can